know that feeling when it seems like an AI is reading your mind, finishing your sentences, translating languages almost instantly? Well, it's not magic. It's a really cool technology called a recurrent neural network, or RNN. And today, we're going to pull back the curtain and see exactly how it works. I mean, we've all seen this a million times, right? You start typing a message and your phone just knows what you're going to say next. It feels a little bit like it's psychic, but the real secret isn't mind reading, it's memory. Yep, the secret sauce is a special kind of artificial intelligence that's built from the ground up to get how sequences work. It has this kind of memory that lets it remember what just happened, so it can make a really good guess about what's coming next. And that special AI has a name, a recurrent neural network, or RNN for short. It's designed to handle what we call sequential data, and that's just a fancy way of saying anything that happens in a specific order. Think about it, words in a sentence, notes in a song, even stock prices over a week. What makes an RNN different is that it doesn't just look at one piece of data at a time. It always remembers what came right before it. Okay, so let's get into the nitty-gritty. How does this whole memory thing actually work? Well, it all comes down to a really clever and surprisingly simple design trick. So take a look at this. You can think of a basic RNN like a conveyor belt at a factory. Each item on the belt, say one word from a sentence, gets processed one by one, moving forward along what we call a time axis. Simple enough, right? But here's the magic trick. Notice that arrow looping back? The information doesn't just go forward, it also loops back on itself. So the result from processing one word becomes part of the starting information for the very next word. That loop is the entire secret to an RNN's memory. And honestly, this is something you do all the time without even thinking about it. When you're reading a book, you're not just looking at each word by itself. Your brain holds on to the beginning of the sentence so that the end makes sense. An RNN is trying to do basically the exact same thing. So if you boil it all down, the process is pretty straightforward. The network gets a new piece of info, it mixes that with what it remembers from the last step, and then it creates a new output. That simple little cycle is the engine that drives this whole thing. All right, so we've got this basic memory loop. Now let's look at how this one core idea can be arranged in a few different ways to power some of the amazing tools we use every single day. First up, we've got the one-to-many setup. And yeah, it's exactly what it sounds like. You give the AI one single thing, and it generates a whole sequence of things back at you. A perfect example of this is image captioning. The AI gets one input, the picture, and it spits out a whole sequence of words that describe it, like a sentence. It's basically turning a single moment into a little story. Now, what if we flip that completely on its head? That gives us a many-to-one architecture. This time, we feed the network a whole bunch of inputs in a row, and it crunches them all down into one single final answer. Think about something like sentiment analysis. The AI reads an entire movie review, a whole sequence of words, and after all that, it gives just one label, positive or negative. It takes a lot of information in to make one simple judgment call. And finally, we have the many-to-many model. This is what you need for the really complex jobs, where you've got a sequence of stuff coming in, and you need a totally different sequence of stuff coming out. Machine translation is the classic example here, right? You feed it an entire sentence in English, that's one sequence, and it gives you back a whole new sentence in French. It's a sequence in and a different sequence out. But, and there's always a but, these basic RNNs have a bit of a weakness. That little memory loop is great for short-term stuff, but when the sequences get really long, they start to struggle. They kind of have a short attention span. The technical term for this is the vanishing gradient problem. Basically, in a really long piece of text, the information from the very beginning gets watered down more and more with every new word, until it's practically gone. The network literally forgets what it read in the first paragraph by the time it gets to the last one. So, what do you do if your AI has a bad memory? Well, you give it an upgrade. Researchers came up with a much more powerful version of the RNN called the Long Short-Term Memory Network, or LSTM for short. I mean, just look at the difference here. On the left, you've got that simple, basic RNN cell we've been talking about. And on the right, that's the LSTM cell. All that extra stuff going on inside is specifically designed to manage memory way more intelligently. It costs more to run for sure, but the payoff is a memory that actually lasts. The big secret to the LSTM is a system of what we call gates. You can think of them like tiny little gatekeepers inside the memory cell that control what information gets to come in, what has to leave, and what gets passed along. This is how they solve that memory problem.
First up is the forget gate. Its whole job is to look at the old memories and the new information and decide what's not important anymore. For example, if it sees a period, it might learn to forget the subject of the last sentence. It's basically doing a little housekeeping.
Next, we have the input gate. This one looks at the new information coming in and decides what's actually important enough to save. It's in charge of updating the cell's memory with fresh, useful stuff, like remembering a new character's name that's going to be important later in the story. And finally, there's the output gate. This gate looks at everything currently in memory and decides what tiny piece of it is the most useful thing to know for the very next step. It makes sure that only the most relevant info gets passed down the line, so things don't get cluttered. So this whole system of gates gives the AI a genuine long-term memory, which totally solves that pesky forgetting problem. It's a huge step up, and it allows for a much, much deeper understanding of language and data, which, of course, leaves us with a pretty big question. Now that AI can properly remember the past, how is that going to shape our future?